So hello guys, in our previous video we have seen that the types of ducts, classification of ducts and the Bernoulli's equation. Now in this class we will solve a numerical. A numerical is the main air supply duct of a air conditioning system is 800 by 600 in cross section. Cross section of a main duct is given 800 by 600 and it carries the 300 meter cube per minute of standard air. So here they have mentioned that it is standard air, so we will take property of standard air. So it branches into two ducts of cross section 600 by 50, 500 and 600 by 400. So and then if the mean velocity of a larger branch is 480 meter per minute, the uh, mean velocity is given of a larger branch which is 480 meter per minute, and then we have to find the mean velocity in the main duct and the branch and the mean velocity pressure in the each duct. So what we have to find here, mean velocity in the main branch and smaller branch, and then mean velocity pressure in the each duct. So we can see the diagram, this kind of diagram we will get. So main duct is here, which is cross section 1 1. Second two branches are there, 2 and 3. So first cross section, one branch cross section is having 600 by 500 and other branch is having 600 by 400 So let us, given that the A1 is equals to 800 and B1 is 600 so in this way we can calculate the area of cross section. Q1 is given 300 meter cube per minute. Q1 is what? Flow rate of air. So we will convert it into meter cube per second. So 300 divided by 60, we will get as 5 meter cube per second. So similarly, A2, B2 we have, A3, B3 is also we have. Now V2 is given. V2 is what? Velocity in a larger branch is given, which is 480 meter per minute. So as we have converted our flow rate into meter cube per second, so we will convert the velocity into meter per second. So velocity is 8 meter per second. So moving towards our solution, the cross section of the duct is shown in the figure. We can see figure the cross section area of main duct A1 is equals to A1 into V1, which is 0.48 meter square. Now cross section of a larger branch, which is A2, is equals to 0.3 meter square, and similarly for smaller branch it is 0.24 meter square. Now our first answer is mean velocity. We have to find the mean velocity in main duct and smaller branch. So we know that the mean velocity of main duct is V1 is equals to Q1 upon A1. We have formula for continuity. Q is equals to A into V. So by that formula, we are having V1 is equals to Q upon A. So in this way, we are having Q and A. So we will get velocity in the main duct, which is 10.4 meter per second. Similarly, we can find for the smaller duct. For that quantity of we have to know the quantity of air passing in small duct. So quantity of air passing through the larger branch is given. Q2 is equals to A2 into V2 is equals to 0.3 into 8, which is 2.4 meters square per second. Now quantity of air passing through the smaller branch, we are having for main branch is Q1 and now we get Q2. So if we subtract them, we will get is 2.6 meter cube per second. We got here Q3 is volume flow rate or flow rate in the smaller branch, and we are having now the velocity V3 is equals to Q3 upon A3. We are having area, we are having the flow rate, so quantity, so we get velocity as 10.8 meter per second. We got all three velocity of branches. Now we have to calculate the mean velocity pressure in each duct. So velocity pressure, we got the formula in last lecture, that velocity pressure is V upon 4.04 whole square, which is in mm of water. So we are having three velocities. Now put into it and get the value of each pressure, velocity pressure or dynamic pressure. For main duct, we got as 6.62 meter mm of water. For the large branch, 3.92 mm of water, and for smaller branch it is 7.14 mm of water. So in this way we can solve the numerical. Now moving towards our next topic, which is pressure loss in the ducts. So there are many kind of pressure loss found in the duct. It can be due to friction, it can be due to bends and other things. Now we will get it one by one. The pressure is lost due to friction between the moving particles of the air and the interior surface of a duct, which is friction loss. And when the pressure loss occurs in a straight duct, it is usually termed as a friction loss. The main loss, friction loss, is also called as a major loss because the main loss or major part of loss is happened due to friction in the duct. And other there are minor losses containing elbow loss and other bending loss and other. So these two types of losses are there: friction loss and other loss. Now, pressure loss also occur during the change in direction of airflow due to inclusion of bend, elbows, etc., and at the change of cross section of a duct. This type of pressure loss is usually termed dynamic loss. So here we have two type of losses: friction loss and dynamic loss. Friction loss is also called as major loss. Dynamic loss is called as minor loss. So these two types of losses we got. Now we have to find the pressure loss due to the friction in duct. The pressure loss due to friction in duct may be obtained by using the Diacres formula. Diacres formula, what it gives: Pf is equals to Fl rho A into V square upon 2m. So we will see all the terms here. Here, Pf is a pressure loss due to friction, which is Newton per meter square. F is a friction factor depending upon the surface. Friction factor is a dimensionless quantity. L is the length of a duct in meters. V is the mean velocity of air moving through the ducts in meter per second. And M is a hydraulic mean depth. Hydraulic mean depth we can calculate with the help of cross section divided by perimeter. So how we can get an cross section or area of a duct A divided by weighted perimeter of a duct B. So A upon P we get M. Now pressure loss due to friction inside the duct. In air conditioning, the pressure loss due to friction in duct is generally expressed in mm of water. Equation can be written as Pf is equals to Fl rho Av square upon 2n. So we have separated m here, and now inside the bracket rho v square upon 2. So in the previous classes we have seen that rho into v square upon 2 is nothing but velocity pressure or dynamic pressure. Now it's denoted by PV, but the velocity pressure is given by V upon 4.0 square whole square mm of water. Now we put into formula, thus we get equation as modified equation of Pf is equals to F into L upon M in the bracket V upon 4.04 square. Now we just have to find friction factor, length we know for the duct, M we have, and now if we get the velocity, so we can easily calculate the friction factor or friction loss inside the duct. When the air is at temperature T degrees Celsius, then pressure loss due to friction in the duct is given by Pf is equals to Fl upon M V upon 4.04 whole square into 273 plus 20 divided by 273 plus T, where 20 is the temperature given. Now Fl upon M V upon 4.0 square whole square 293 upon 273 plus T mm of water. For a circular duct, the diameter D of a hydraulic mean depth M is given by A upon P. We get as D by 4. M we get as D by 4. For the rectangular duct, we are having side A and B. So we will get area is equal to A into B and perimeter as 2 into A plus B. Now we get formula as AB upon 2 into A plus B. For the circular duct, m is equals to d upon 4, and for the rectangular duct ab upon 2 into a plus. In this way we can calculate the friction loss and dynamic friction loss. Now that's all for this class, and that's all for today. So we will see our next content in next video.